Hello everyone, welcome to aviation engineering YouTube channel. Okay, so today I will take a kind of different lesson. So this lesson is including the fundamental of aircraft engine maintenance. So if you like to learn about aircraft engine maintenance, so this is the right video for you. So in this video I will give you some information about aircraft engine maintenance. So this video actually based on reciprocating engines, and I will discuss and I will tell you the informations regarding the gas turbines and kind of types of engine types and how to maintain. So stick with the aviation engineering YouTube channel. So if you still not subscribe to aviation engineering YouTube channel, please subscribe and also share these videos with your friends, relatives, and anyone who like to learn about aircraft maintenance. And if you are new to aviation engineering, I'm Kesha Vikramasinghe. I'm a professional aircraft maintenance technician. So and also I want to tell about this channel. So this channel I'm discussing about aircraft maintenance procedures and also Airbus ATA chapter wise lessons, and also some of the informations regarding the crashes happened before. All right, so no need to waste the time. Let's go to the lesson. All right. Okay, so today lesson is about the fundamental of aircraft engine maintenance. All right. Okay, let's go forward. Alright, so the lesson contains the introduction, engine types and engine components, and especially I'm talking about engine components, the reciprocating engine, piston engines. So the gas turbine engine, when I'm talking about Airbus ATA chapter 70 to 78, I will talk about the gas turbine engine, the components, but this is like a introductions, and so this is like a basic knowledge for you. So that's why I'm talking about reciprocating engines. All right, so and also the inspection procedures and finally the conclusion. All right, so let's go to the lesson. All right, the first one is introduction. So the first one, the importance of engine maintenance, right? Importance of engine maintenance. You can see this is gas turbine engine, right? So the first one is maintain engine performance and longevity, right? And also the prevent unexpected engine failures and ensure flight safety, and reduces maintenance cost in the long term and increases the resale value of the aircraft. All right, so now let's go one by one. All right, so the first one maintains engine performance and longevity, right? Maintains the engine performance and longevity. Okay, let's see the description. So engine maintenance is essential for maintaining engine performance and longevity, right? So regular inspection, right, and cleaning and replacement of worn or damaged parts help keep engine running at peak efficiency and prevent unexpected failures. This helps ensure safe and efficient flight, reduce maintenance cost, and increases the resale value of the aircraft. All right, okay, you can see this is the gas turbine engine. All right, so let's go to the next one. Prevent unexpected engine failures. Okay, this is the engine failure when the aircraft is flying, right? So prevents unexpected engine failures. So engine maintenance helps prevent unexpected engine failures. So by regular inspecting, cleaning, and replacing worn or damaged parts, or potential problems can be identified and addressed before they cause a failure, right? So this reduces the risk of in-flight accident incidents and improves the reliability and safety of the aircraft operation. So investing in regular engine maintenance is a crucial step in ensuring safe and efficient flight. All right, okay. So the next one ensures flight safety, right? Flight safety is very important, right? Okay, so engine maintenance plays a critical role in ensuring flight safety. So by maintaining engine performance and preventing unexpected failures, it helps reduce the risk of in-flight accidents, right? So regular inspection and preventive maintenance helps to identify potential problems and address them before they lead to a failure. So this helps ensure that the aircraft engines are operating at peak efficiency and reliability contributing to safe and successful flight operations. All right. Okay, next one, reduces maintenance cost in the long term, right? So regular engine maintenance can reduce maintenance cost in the long term, right? So by keeping engine running at peak efficiency and preventing unexpected failures, it reduces the need for costly repairs and unscheduled downtime. So early identification and resolution of potential problems can also help prevent more significant and expensive issues for developing. So by investing in regular engine maintenance, aircraft operators can save money and ensure the continued safe and efficient operation of the aircraft. All right. Okay, the last one, the increases the resale value of the aircraft. Resale value, right? So regular engine maintenance increases the resale value of the aircraft. So it shows a history of proper care and maintenance, making the aircraft more attractive to potential buyers and increasing its market value. This makes engine maintenance an important factor in maintaining a long-term value of aircraft assets. All right, so this is the introduction. All right, so now the next one, the under introduction, the overview of engine types and components, right? Overview of engine types and components. Okay, you can see the engines, right? This is the turboprop, right? Okay, so the first one, reciprocating engine. Reciprocating engine, you can call it as a piston engine, right? So reciprocating engines use a piston to convert pressure in a rotary motion and are found in automobiles, motorcycles, aircraft, and power generators. All right. So now the gas turbine engines. This is the engine now we are using for special for Airbus, right? Airbus and Boeing. So the gas turbine engines produce thrust by expelling a high-speed jet of air and are used in aircraft, missiles, and space rockets. They can be further clarified into turbofan, turbojet, and turboprop engines. So engine components. Engine consists of several basic components including fuel system, air intake system, combustion chamber, turbocharger, lubrication system, and exhaust system. And next one, engine performance, right? So engine performance is measured in terms of thrust, fuel, efficiency, noise, and emission. The choice of engine depends on the specific requirements of the application such as speed, range, and payload. So next one, advancement in technology. Advancement in technology. With advancement in technology, engines have become more efficient, environmentally friendly, and capable of producing high power outputs. New materials and design techniques are being used to improve engine performance and reduce weight. All right. So this is the overview of engine types and components. All right. Okay, now let's go to the engine types. Engine types, right? So under engine types, you can see the piston engine. Piston engines, it can be divided into reciprocating engine and radial engines. And then the turbofan engine, turboprop engine, and jet engine. All right, so let's go one by one. Under piston engine, the first one, reciprocating engine. You can see this is the reciprocating engine, right? So the reciprocating engines are internally combustion engines that are use a piston to convert pressure into rotary motion. So these engines are found in many applications, including automobiles, motorcycles, aircraft, and power generators, right? So reciprocating engines are classified into two types, right? Two-stroke and four-stroke engine. Just remember, based on the number of strokes required to complete a single combustion cycle. So they are characterized by high power output, durability, and reliability. However, they are relatively heavy and produce significant amount of pollution. Okay, that is also some problem. So which has led to the development of alternative engine technologies. Despite this, reciprocating engines continue to be widely used and play a vital role in modern transportation and energy systems. All right. So now let's go to the radial engine. So this is the radial engine, right? So the radial engines are type of reciprocating engine. So radial engines also type of reciprocating engine. So characterized by having multiple cylinders arranged in radial pattern. So used in many World War II era aircraft, right? World War II aircraft, they are using so many radial engine aircraft and known for their reliability and durability and produce high power output with low weight. So hard large propellers providing better lift and speed. So low fuel consumptions compared to inline engines and large frontal area resulted in increasing drag. So less common in modern aviation, replaced by turbofan and turbojet. jet engine. Now radial engines replaced by the turbofan and turbojet engine. So however, still using some small aircraft and vintage planes. Still the radial engines will be using for some small aircraft like Cessna and also the vintage planes, right? Okay, now let's go to the turbofan. Turbofan, this is the turbofan engine. So there are so many kinds: high bypass engine, low bypass engine, right? So I will discuss these kind of engines under it is chapter 71 to 78, right? Okay, so the turbofan engines are a type of gas turbine engine. It is a type of gas turbine engine. So characterized by a fan at the front of the engine. There's a big fan in the front of the engine which compresses air before combustion, right? So it means the air come to the fan and it compress the air before it go to the combustion chamber. Provide high thrust and fuel efficiency. So used in commercial and military aircraft. And two types I told you: low bypass ratio and high bypass ratio. So high bypass ratio turbofans have larger fans providing more efficient thrust. So low bypass ratio turbofans are used in military aircraft for high thrust, right? Significant reduction in noise and emissions compared to early engine like reciprocating and radial engines. So continuous improvement in technology has led to more efficient and powerful turbofan engine. All right. Okay, now let's go to the turboprop engine. Turboprop engine, it means this engine is consist of propeller and also the gas turbine, right? So the turboprop engines are type of gas turbine engine. So use a propeller to produce thrust. Remember, in the turbofan engine, the fan is used to produce the thrust, and fan take the air and is compressed and sent to the combustion chamber. In this the turboprop engine, the propeller is produced thrust. Okay, so idle for small or to medium size aircraft is idle for small to medium size aircraft, right? Especially those used in regional air transportation, right? So provide high fuel efficiency, lower noise and emissions compared to piston engine. So propeller is driven by the power turbine, which is connected to the engine's gas generator. High power to weight ratio and generally slower than turbofan engine, but offer better short field performance. So used in regional airlines, cargo planes, military trainers and utility aircraft. So advancement in technology have led to improved efficiency and reliability of turboprop engines. All right. Okay, let's go to the jet engines. Okay, this is the jet engine. So jet engines are a type of gas turbine engine. Jet engine is also a type of gas turbine engine that produce thrust by expelling a high-speed jet of air, right? So they are used in the wide range of applications, including commercial and military aircraft, missiles and space rockets. So jet engines can be classified into two types, right? Turbojet and turbofan engines, right? So turbojet engines rely solely on the hot gases expelled from the combustion chamber to produce thrust, while turbofan engines utilize a fan at the front of the engine to compress air and increase the overall efficiency. Jet engines are characterized by their speed, efficiency, and long-range capabilities. They have revolutionized air transportation, making long-haul flights faster, more comfortable, and more accessible, right? With continued advancement in technology, jet engines are becoming increasingly fuel efficient and environmentally friendly, all right? Okay. Yeah, now the third one, engine components, right? In this section, I want to tell in this section, mostly I focus on the reciprocating piston engines. So gas turbine engines, I will teach you later lessons, right? Okay, so let's see the under engine components. You can see the piston, crankshaft, cylinders, valves, fuel system, lubrication system, right? Okay. So now the pistons. Okay, you can see these are the pistons. So these are the introductions for the the description about the pistons. So pistons are an essential component in reciprocating engine. I told you about the reciprocate, right? So pistons are essential component in reciprocating engines and play a crucial role in converting pressure into rotary motion. So a piston is a cylindrical component. It is a cylindrical component that fits inside the engine cylinder and moves up and down. It's move up and down to compress and expand the air-fuel mixture. So the up and down motion of the piston is used to generate power and drive the crankshaft, which is turn rotates the wheel or the propels the aircraft. So pistons are made from high strength material. Remember, the pistons are made from high strength materials such as aluminum or steel and are designed to withstand high temperatures and pressures. So they are coated with low friction materials to reduce wear and improve efficiency. Pistons are an integral part of the internal combustion engine and play a vital role in its performance and reliability. Alright, okay, now let's go to the crankshaft. Okay, this is a crankshaft. So the crankshaft is a key component in reciprocating engine. Remember, in reciprocating engine, crankshaft is a key component, right? And is responsible for converting the linear motion of the piston into the rotary motion, right? From the crankshaft, that is the one is used to convert linear motions to rotary motion. So the crankshaft is a long metal shaft that runs along the engine center line and is connected to the piston through connecting rods. As the piston move up and down, they transfer their motion to the crankshaft, causing it to rotate. So this rotation is then transmitted to the drivetrain, which propels the wheels or the aircraft. The crankshaft is made from high-strength materials such as steel and is designed to withstand high loads and stresses. It is dramatically balanced to reduce vibrations and ensure smooth operations. The crankshaft is a critical component in the reciprocating engine and plays a vital role in its performance and efficiency. Alright? Okay, now the cylinders. Okay, you can see these the cylinders, right? So the cylinders are an essential component in reciprocating engine. These are also very essential components and are responsible for containing the air-fuel mixture that is burned to produce power. Right, so a cylinder is a hollow metal chamber that houses the piston and is connected to the engine's intake and exhaust system. The cylinders are arranged in line along the engine center line and are sealed at one end by a cylindrical head. Right, so the movement of the piston inside the cylindrical creates pressure and drives the crankshaft, which is turned rotates the wheels or propels the aircraft. Cylindrical are made from high strength materials such as cast iron, right? Cast iron or aluminum, and are designed to withstand high temperatures and pressures. They are coated with the low friction materials to reduce wear and improve efficiency. So cylinders are an integral part of the reciprocating engine and play a critical role in its performance and reliability. Alright, okay, I just named. You can just skip, just pause the video and just look at this picture. Alright, now the valves. Okay, valves. So the valves are an important component in reciprocating engines and are responsible for controlling the flow of air and fuel in and out of the cylinders. So valves are typically located in the cylinder head and are operated by the camshaft. There are two types of valves, right? Intake valves and exhaust valves. There are two types of valves, intake valves and exhaust valves. So intake valves control the flow of air and fuel into the cylinder, while exhaust valves control the flow of exhaust gases out of the cylinder. Alright, so valves are designed to open and close rapidly and precisely, allowing for optimal combustion and power production. So they are made from high strength materials such as steel and are designed to withstand high temperatures and pressures, right? So the valves play a critical role in the performance of efficiency of the reciprocating engine, and proper valve function is essential for reliable engine operation. All right. Okay, now the fuel system. Right, fuel system also very important. So the fuel system is a critical component. It is a critical component in reciprocating engines and is responsible for delivering fuel to the engine. So the fuel system consists of several components including fuel tank, fuel pump, fuel injectors, and a carburetor or a fuel management system. The fuel tank stores the fuels while the fuel pump delivers it to the engine under pressure. The fuel injectors are responsible for introducing the fuel into the air-fuel mixture in precise quantities, while the carburetor or the fuel management system is responsible for controlling the air-fuel mixture composition. Right? So the fuel system must deliver fuel in the correct quantity and at the right time to ensure proper engine performance. Proper fuel system function is essential for the efficient and reliable operations of the reciprocating engine. Alright, Okay, now the lubrication system. Lubrication system is a crucial component in reciprocating engine and is responsible for reduce friction, preventing wear, and maintaining engine temperature. Same as fuel system, lubrication system also very critical component in reciprocating engine. So the lubrication system consists of several components, including an oil pump, oil filter, oil cooler, and oil passage. So the oil pump circulates oil through the engine, delivering it to the critical components such as crankshaft, bearings, and cylinder walls. The oil filter removes contaminants from the oil, while the oil cooler helps regulate engine temperature by dissipating heat. The oil passage are channels drilled into the engine block that allows oil to flow to where it is needed. So the lubrication system must deliver clean oil, right? Lubrication system must deliver clean oil in the correct quantity to ensure efficient and reliable engine operations. Proper lubrication is essential for preventing engine damage, reducing wear, and improving engine performance and efficiency. Okay, you can pause the video and you can just get an idea about the lubrication system from this picture. All right, yeah. Now let's go to the inspection procedures. Okay, there are some inspection procedures. First one is a pre-flight inspection, scheduled maintenance inspection, troubleshooting, and engine removal and disassembly, right? So let's go one by one. The first one is pre-flight inspection, right? Pre-flight inspection. Okay, let's see the description. Pre-flight inspection is a critical step in the aviation process and is performed before every flight. Okay, pre-flight inspection will do before every flight. So it involves a comprehensive check of the aircraft, its system, and its equipment to ensure that it is safe and ready for flight. The purpose of pre-flight inspection is to identify potential problems or malfunctions that could compromise the safety of the flight and to address these issues before takeoff. This inspection includes a visual inspection of the aircraft, checking fuel levels, performing through the check of the engine and system, and checking control surfaces and verifying the communication and navigation equipment is working properly. So the pre-flight inspection is a critical safety procedure and is essential for ensuring a safe and successful flight. Alright. Okay, now let's go to the scheduled maintenance inspection. Scheduled maintenance inspection. So the scheduled maintenance inspections are an important aspects of aircraft maintenance and play a crucial role in ensuring the safety and reliability of the aircraft. So these inspections are performed at regular intervals, right? And their purpose is to identify and address any potential problems of wear and tear before they become more serious, right? So the following are 5 key points that make up a scheduled maintenance inspection. Let's see. The first one is inspection scope, right? So the scope of inspection is determined by the type of aircraft, its age, and the amount of use it has seen. So this information is used to determine the specific areas that need to be inspected and the frequency of the inspection. And next one, inspection procedure, right? The inspection procedure are determined by the aircraft manufacturer and are designed to identify any potential problems or wear and tear. So this may include checks of the engine and system and control surfaces. And now the inspection tools, right? The inspection tools used during a scheduled maintenance inspection may include specialized equipment such as borescope or ultrasonic inspection tools to help identify potential issues. Next one, inspection records. So all inspection results are recorded and kept as a part of the aircraft maintenance records, and these records are used to track the history of aircraft and to identify any trends or patterns that may indicate a need for further inspection. And last one is maintenance action. So if any issues are identified during scheduled maintenance inspection, they are addressed through the appropriate maintenance action, such as repair or replacement of the parts. The goal is to ensure that aircraft is good condition and ready for flight. All right. Okay. Now the troubleshooting. So the troubleshooting is the process of identifying the solving problems in an aircraft. So it involves analyzing symptoms, determining the root causes of the problems, and implementing corrective action. Troubleshooting can involve checking systems, engines, and components, as well as conducting test and inspection to determine the source of the issue. So it is a critical aspect of aircraft maintenance and is essential for ensuring the safe and reliable operation of the aircraft. So troubleshooting can be performed by trained professionals, right? Troubleshooting will be doing by trained professionals or by the pilot during flights. So and it's an important aspect of the overall maintenance and safety programs for aircraft. All right, and the last one, engine removal and disassembly. Engine removal and disassembly. Okay, so the engine removal and disassembly is a complex process that involves removing the engine from the aircraft and breaking it down into its individual components for inspection and repair. So this process is typically performed during major overhauls or where there is significant problems with the engine. So engine removal and disassembly requires specialized tools and knowledge and is usually performed by trained technicians. So the goal of this process is to thoroughly inspect the engine, identify any problems of wear and tear, right? So wear and tear, and make necessary repairs to ensure the engine is in good condition and ready for flight. Engine removal and disassembly is an important part of the overall maintenance program for aircraft and is essential for ensuring the safety and reliability of the aircraft. All right. Okay. So now let's go to the conclusion. Direct conclusion, right? So the conclusion, you can see importance of the regular engine maintenance and importance of proper inspection procedures. Okay, let's discuss these two points. The first one, importance of regular engine maintenance, right? So the regular maintenance of aircraft engine is crucial to ensuring the safe and reliable operation. The following are the 4 key reasons why regular engine maintenance is so important. The first one is prolonging engine life. So regular maintenance helps prolong the life of aircraft engines by identifying and addressing any issues of wear and tear before they become more serious. So this helps keep engine in good conditions and reduce the need for more costly repairs down the road. All right. Next one, enhancing engine performance, right? Regular maintenance helps keep engines operating at their optimal performance levels. This enhances fuel efficiency, reduce emissions, and improve overall flight performance. Next one, enhancing safety. Regular engine maintenance helps ensure the safety of the aircraft and their passengers by identifying and addressing any potential problems or malfunctions before they become more serious. Next one, maintaining compliance and the regulations. Regular engine maintenance is required by regulatory bodies such as Federal Aviation Administration, or as you can say EASA, right? European Safety Aviation Agency, right? EASA, to ensure that aircraft are in compliance with their regulations and standards, right? Regular maintenance helps to ensure that aircraft are operating with these guidelines, which is essential for ensuring the safety of aircraft and their passengers. Okay, now the importance of proper inspection procedures, right? So the proper inspection procedures are essential for ensuring the safety and reliability of aircraft. So these procedures help identify potential problems and wear and tear, allowing for timely and effective maintenance of actions to be taken. So proper inspection procedures also help ensure that aircraft are operating with the regulatory standards and guidelines, and can help prolong the life of the aircraft and its components. So regular and thorough inspections are critical aspects of aircraft maintenance and help ensure that aircraft are in good conditions and ready for flight. All right. Yeah, that is the end of this lesson. Okay, so I think you got a fundamental knowledge of aircraft engine maintenance. So I'm planning to do some videos regarding how to become aircraft maintenance engineering organization CEO, director, aircraft mechanic. So I will make a lessons for these kind of things, so you can learn and you can get more knowledge about this kind of thing, this kind of topics. And also I will still am preparing the lessons regarding chapter wise. So maybe next week I will going to put AD chapter 27 flight controls. So these lessons also very useful. So yeah, thank you for participating this lesson, and thank you very much for staying until the end of this lesson, because this lesson is a little bit longer. So and also I want to tell you, don't forget to subscribe this Aviation Engineering YouTube channel, because if you only subscribe, I can grow my YouTube channel and I can give you more knowledges. So because to make these lessons, I'm searching so many website, and I get so many knowledge, and then I put to the presentation, and I will give to you. So it's good for you. All right. And also share these videos with your friends, relatives, and anyone who like to enter aircraft maintenance field. All right. So that's all for today. So let's meet on next lesson. Have a good day for all of you.